Hello students, welcome to the channel SNW Physics Classes. If you really understand the concepts taught here, please turn the black thumb blue. That means like the video, share with your friends and subscribe to the channel SNW Physics Classes. Do not forget to hit the bell icon for the latest updates. Stay connected with me on Facebook, Instagram, or you can write using my Gmail ID. Links are given in the description box. This is the series of NCERT solution and we are going to solve exercise question answer of chapter 1 physics, that is electric charges and waves. This is the fifth part of this video. For the other 4 parts, you can click on the link given in the description box. In this video, we are going to deal question number 1.21 to 1.24 of class 12th. So let's begin with the video. Question number 1.21. A conducting sphere of radius 10 centimeter has an unknown charge. Okay, here is a conducting sphere whose radius is 10 centimeter. If the electric field 20 centimeter from the center of the sphere is 1.5 into 10 to the power 3 Newton per coulomb and point radially inward, what is the net charge on the sphere? Let us suppose a point P which is 20 centimeter away from the center of the sphere, then we have to find out what is the net charge on the sphere. ठीक है, एक स्फेयर है जिसका रेडियस जो है वो 10 सेंटीमीटर और इसके पास जो चार्ज है दैट इज अननोन. इफ एट पॉइंट P, okay, which is 20 centimeter away from the center से उसका जो डिस्टेंस है पॉइंट P का दैट इज 20 सेंटीमीटर and its electric field is 1.5 into 10 to the power 3 Newton per coulomb. तो हम लोगों को find out करना है what is the net charge on the sphere. Let us see the solution here. Electric field intensity at a distance d from the center of sphere containing net charge q is given by the relation. सबसे पहले हम लोग electric field का relation देखेंगे, that is E is equal to 1 by 4 pi epsilon naught q by r square. Okay, here it is given the value of E की value दी हुई है 1 by 4 pi epsilon naught. We know the value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. R it is given that is 20 centimeter. Let us see, here it is given that 1.5 E is equal to 1.5 into 10 to the power 3 Newton per coulomb. Distance is 20 centimeter, that is 0.2 meter. So we will put the value of these two E and D. 1.5 into 10 to the power 3, that is the value of E. 1 by 4 pi epsilon naught, 9 into 10 to the power 9 into Q divided by R square, that is 0.2 into 0.2. On calculating this, we will get 6.67 into 10 to the power minus 9 coulomb, which is equal to 6.67 nano coulomb. ठीक है, minus 9 को हम लोग लिख सकते हैं nano coulomb. Therefore, the net charge on the sphere is 6.67 into 10 to the power 9, which is also equal to nano coulomb. This is the required answer. Question number 1.22. A uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80.0 microcoulomb per meter square. Okay. Surface charge density है, let us consider a sphere whose diameter is 2.4 meter और radius हम लोग find out करेंगे तो 1.2 meter हो जाएगा. Okay, then we have to find out the charge on the sphere. Also we have to find out the total electric flux leaving the surface of the sphere. ठीक है, let us see the solution here. Diameter of the sphere is d is equal to 2.4 meter. Radius of the sphere will be 1.2 meter. Here it is given that surface charge density is 80.0 microcoulomb per meter square. ठीक है, इसको हम लोग microcoulomb की value यहाँ पे लिखेंगे 10 to the power minus 6 coulomb per meter square. Okay. Next, the total charge on the sphere, surface of a sphere, can be calculated by using this formula. Q is equal to charge density into surface area. ठीक है, charge density it is represented by sigma into 4 pi r square. Surface area of a sphere. Okay. It is given that surface charge density is 80 into 10 to the power minus 6. ठीक है, 4 into pi की value हमने यहाँ पे put किए 3.14 into r square, that is the radius of the sphere, 1.2 square. On calculating this, we will get 1.447 into 10 to the power minus 3 coulomb. Therefore, the charge on the sphere is 1.447 into 10 to the power 3 coulomb. This is the answer to this question. Question number 1.23. An infinite line charge produces a field of 9 into 10 to the power 4 Newton per coulomb at a distance of 2 centimeter. एक infinite line charge है, okay, और वो 2 centimeter distance पे उसका जो electric field है that is 9 into 10 to the power 4 Newton per coulomb. Then we have to calculate the linear charge density. Let us see the solution. Electric field produced by infinite line charges at distance d having linear charge density lambda. Linear charge density को हम लोग lambda से represent करते हैं. It is given by E is equal to lambda by 2 pi epsilon naught d. ठीक है, lambda की वैल्यू निकालने के लिए we will cross multiply these two expressions. यहाँ पे 2 pi epsilon naught d into E. It is the equation 1. It is given that d is equal to 2 सेंटीमीटर. इसको कन्वर्ट करेंगे मीटर में तो या तो हम लोग लिख सकते हैं 2 into 10 to the power minus 2 और we can write 0.02 meter. E electric field it is given that 9 into 10 to the power 4 Newton per coulomb. Epsilon naught की वैल्यू हम लोगों को पहले से मालूम है that is 8.854 into 10 to the power minus 12. Okay. Now putting these values in equation 1, lambda is equal to 2 pi epsilon naught into 2 into 10 to the power minus 2. ठीक है, इस 2 सेंटीमीटर को हम लोगों ने मीटर में कन्वर्ट किया. इस ये पूरा जो हमारा एक्सप्रेशन है that is the distance d into E that is 9 into 10 to the power 4. ठीक है, 2 into 2 we will get 4 pi epsilon naught. ठीक है, 1 by 4 pi epsilon naught की वैल्यू है 9 into 10 to the power 9. तो 4 pi epsilon naught की वैल्यू हो जाएगी 1 by 9 into 10 to the power 9. Here we will write 1 by 9 into 10 to the power 9 into this 10 to the power minus 2. Okay, into 9 into 10 to the power 4. On calculating this, ये 9 हमारा cancel हो जाएगा. Okay, this 9 and this one. सारे powers को हम लोग जब calculate करेंगे, then we will get 10 to the power 10 into then we will get 10 to the power minus 7 coulomb meter, or we can write 10 into 10 to the power minus 6 को हम लोग लिख सकते हैं micro coulomb. So here the required answer is the linear charge density is 10 micro coulomb. Question number 1.24. Two large thin metal plates are parallel and close to each other. ठीक है, यहाँ पे दो plates हम लोग thin metal plates लिए हुए हैं. Okay, they are placed parallel and close to each other. दोनों को हम लोगों ने parallel रखा और दोनों एक दूसरे के बहुत close हैं. On their inner faces, the plates have surface charge density of opposite sign and of magnitude 17.0 into 10 to the power minus 22 coulomb per meter square. ठीक है, इन दोनों का जो inner faces है, इन पे जो charges हैं वो opposite sign के हैं और उसका magnitude है 17.0 into 10 to the power minus 22 coulomb per meter square. Then we have to calculate what is E. ठीक है, इलेक्ट्रिक फील्ड हम लोग को कैलकुलेट करना है. कहाँ पे कैलकुलेट करना है? आउटर रीजन ऑफ द फर्स्ट प्लेट. ठीक है, फर्स्ट प्लेट के आउटर रीजन मींस दिस इज रीजन एंड आउटर रीजन ऑफ द सेकंड प्लेट. ठीक है, सेकंड प्लेट का भी आउटर रीजन दिस वन एंड बिटवीन द प्लेट्स यानी रीजन 2. लेट अस सी द आंसर हियर. अगेन हियर इज द प्लेट्स. यहाँ पे फिगर हम लोगों ने फिर से लिया हुआ है. सोल्यूशन इज parallel plates A, B are placed close to each other. Okay, as shown in figure. The region between plates A and B is labeled as 2. दोनों के बीच का region है, it is labeled as 2. Outer regions of plate A is labeled as A. Okay, sorry, 1 है यहाँ पे. Outer region of plate B is labeled as 3. Now the charge density of plate A can be calculated. पहले charge density जो हमारा given है 17.0 into 10 to the minus 22 coulomb per meter square. Also similarly the charge density of plate B, क्योंकि opposite charge है यहाँ पे, opposite equal and opposite charges are there, so charge density will be minus 17.0 into 10 to the power 22 coulomb per meter square. Again in region 1 and 3 means ये वाला region और this one. Okay, electric field E is 0 because the charge is not enclosed by the respective plates. ठीक है, plates जो है वो charges को enclose नहीं कर रहे, इसलिए region 1 और region 3 में जो charges होंगे, electric fields होंगे, that is 0. Now Let us proceed to the next question. Electric field E in the region 2, यानी इन दोनों plates के बीच में. Okay, it is given by epsilon naught into sigma, that is surface charge density. Again, we will put the value of epsilon naught and also the value of surface charge density. So now electric field is equal to 17.0 into 10 to the power minus 22 multiplied by the epsilon naught, that is 8.854 into 10 to the power minus 12 कूलम स्क्वायर पर न्यूटन मीटर स्क्वायर. ठीक है, इन सबको कैलकुलेट करके मल्टीप्लाई करके वी विल गेट 1.92 into 10 to the power minus 10 Newton per coulomb. This is the answer to this question. Therefore, the electric field between the plates is 1.92 into 10 to the power minus 10 Newton per coulomb. If you have any doubt, any confusion related to any question in this video, please comment in the comment section. Like, share and subscribe to my channel. Thank you very much for watching.